Hello friends, we are continuing with our series of videos on cuda. So the first video was on HPC and details, and second video was on introduction to Jetson Nano. And now this video is going to be a programming, the cuda program, and how to create a hello cuda example using Jetson Nano. So as you can see on the screen, what is cuda? Actually, cuda is a parallel programming platform and an API model that was developed by NVIDIA. Using cuda, one can always utilize the power of NVIDIA GPUs to perform the general computing tasks such as multiplying matrices and performing other linear algebra operations. And we have taken a lot of information from tutorial point. And so this is how the first program looks like. It's, let's call it a hello world using cuda.cu, and every program is written with an extension cu in cuda, unlike in C, which is a small c means a normal C file, capital C means it's a C++ file. Now, like in normal C language, we are having the stdio.h, the library, and we have to include a library called cuda.h whenever you do cuda programming. So as you can see on the screen, the program begins with the main. So the first line itself says that you are going to launch a kernel with one block and one thread. This is what it means, 1, 1. So, and the kernel will execute a function called cuda_hello, which is written in the global function. So this part is going to be executed in the GPU, inside the GPU. This will be inside the CPU. So this calls this function, gets executed there, and prints hello world from GPU. And the next line is very important. That is, this is running at a very fast speed. This is at a slower speed. So cuda device synchronize is compulsorily to be written. This is for the device synchronization. You can see in the picture. So one block, the kernel, launched kernel, has got a block and a core. Inside one core 1, this hello world was executed. So as you can see here, and you can simply go to nano hello world using cuda, and it opens up the file, and you can do nvcc that particular file name. Here file name is a bit different from what I showed you in the first slide. And you get a.out and you can execute, and then output comes. And you always have to do a profiling. Profiling is nothing but trying to understand how much time and resources are used by the GPU, taken by the GPU to execute this particular a.out. So this is how the profiling of the a.out looks like. You can see GPU activities 757 microseconds it took to just print word hello world. And remaining are the API calls, etc. That is more responsible for the CPU GPU communication, which we can ignore. We are more concentrating on this number 757.21. So now suddenly if we try to change the program with the kernel 1, 3, that means you have one block and 3 threads. This is how it looks like. And you are trying to run this program. Let's say what is the difference is going to be between 1, 1 and 1, 3. So naturally you know that actually all these yellow places there is going to be a function sitting cuda hello, and will be executing hello world from CPU. The 3 hello world from CPU has to be there. So you can see just nano compile and nano editor where we have written this program, and it is going to execute, and you are going to simply type nvcc -o op hello.cu, and output file is this one. Instead of a.out, now we have op, and output prints 3 hello words. If when I profiled, actually you can see that it's taking 771 microsecond. You remember in earlier case when we were profiling, it was taking 757 microsecond. So there is a small difference, 751, 761, 771, 20 microsecond more it took. And the usefulness of all CUDA programs are not to execute such kind of simple things, printf, etc. When you really do the calculation, these numbers are very, very significant. You will see that. And even if you increase the number of threads, this is not going to make much difference between one thread or 2, 3 thread. The timing will be around microseconds. So that is what we are trying to do. Now we can go into the demonstration of this. Actually, whatever we are done. Now we are getting into the Jetson Nano, which is sitting across the room, and the IP number of that is known to me. So just logging into the system, and this is how Jetson Nano Linux. This is a Ubuntu system 18.04, and here you, like in a Linux system, you can type ls and try to see what it has, and you can see pwd, that means the present working directory, that's home Joby. And now you can see there are so many files there, and we are going to open the file which we are talking about, nano, then hello world using CUDA. So when you open this, so this is how the program is written. The first program 1,1, the kernel is launched with 1,1. You can see that here. And now let's execute this program and profile it. So nvcc, and we simply say this. So it executed in this machine. So it gives an a.out. So we are running a.out to see one time it is printed from the thread. Now if you do the profiling of this using sudo nbprof, then /a.out, it's going to profile and throw it to you. So this is what we were seeing, 755 microseconds it took actually to execute one program. Now in the next program, when right now if you try to change the program to 3 threads, so this is how you change it. And one block and 3 threads, that means it is supposed to print from 3 different threads. And let us execute this program and see how much difference it makes in the profile. So now again we are running the program, and see a.out, it shows 3 times it will print. It has printed 3 times from 3 different cores of the block, same block, when we are doing the profiling. So instead of 755 microsecond, now how much time it is going to see? You can see 755 microsecond in the earlier program. Now in this particular, it is taken only 769 microsecond. So it doesn't mean that 3 times means 3 times the speed is increased. The time, GPU time is also going to increase. That it is not so. So that is what the point we wanted to. So, okay, see you in the next video.